Hello everyone. In our previous session, we discussed about string data type in JavaScript. Today, we are going to cover number data type in JavaScript. So we are going to talk about this data type in detail, and we will be covering as many aspects about this data type as possible. So let's get started. So there are few important points you'll have to keep in mind while using the number data type. The first point here is the number type represents both integer and floating point number. So there are no separate data type for representing the floating point numbers in JavaScript. The number data type itself is used to represent both integer values as well as the floating point values. So if you run these two lines, where in the first line I have used an integer value and in the second line I have used a floating point number or a decimal number, then both these statements will print number as the type. So I'm using this type of operator to find the number of the given value. So yeah, so we don't have any separate data type for storing floating point numbers. The next point is like JavaScript numbers are stored as double precision 64-bit format IEEE 754 value. So if you talk about the internal structure, how the number value is stored internally by JavaScript, then this is how the values are being stored. JavaScript uses the 64-bit format where it divides in the entire value in three parts. The first part is sign, the next part is exponent, and the third part is the fraction, or you can also call this mantissa or significant, so whatever you like. So the most of the bits are taken by the fraction. So we are going to talk about this representation of number in detail in our next session. So this is just for your information for now. We are not going to deep dive into this, and in next session we will talk about and we will go through about go through with an example how to convert a number to its 64-bit format IEEE 754 value. So this is very interesting, and this also gives you answers to lots of problems that we face while using the number. Another thing that you need to keep in your mind is like big integer values with greater than 15 digits are not always correctly represented. So I will walk you through a couple of examples where the values are not correctly represented, and sometimes their value is changed when we try to use the big integer values, and that leads to the uh, uh, mistakes or errors in the computations. The next point is the maximum precision value is 17. So JavaScript number can only contains maximum 17 digits. So the precision is only 17. You cannot have a number which can have 18 digits. The maximum digits allowed in the JavaScript number is 17. Any number which is more than 18 cannot be represented correctly by the JavaScript. Okay, the next part is infinity, minus infinity, and nan are a special type of numbers. So you might have seen this nan error as well. Lots of places we always encounter into nan errors. So nan stands for not a number. So whenever we try to do any calculation where the calculation doesn't yield into a number, then it gives the errors. For example, if we try to divide a string value with some number, then it will give nan, because you cannot divide a string with a number, or you cannot divide a number with a zero. So when you try to do that, it will give you an nan error, but still nan is represented as a number. So this is a special type of number. If you run this command console.log type of nan, then it will give you number. Similarly, infinity and minus infinity are also some reserved numbers are which have the number type, and any value which can be represented by JavaScript is less than infinity, and that value is always greater than minus infinity. So we will see a couple of examples where we can use this infinity and minus infinity, where we want to compare with the extremely large value, or we want to compare our number with an extremely small value. Then we can use these two variables, two keywords. All right, let's move to next slide. In this slide, I have written down some important functions that can be used with the number data type. So we'll go through these functions one by one. So in the first point, I have mentioned isFinite and isNaN function. So as the name suggests, these functions are used to check if the number is finite or NaN. So we can use these functions to check the validity of the number. And if we want to start doing any calculation, and we want to make sure that we don't run into any errors, then we can make sure that we are going to use the valid numbers by using these functions. The next function is toString, and as a parameter we can pass any base value, and this function can be used to convert a number to any base type. Value of base can vary from 2 to 36. So in this code snippet, I have taken number 12, and I'm trying to convert this number 12 to binary and hexadecimal by passing 2 and 16 in toString function. So when you run these statements, the respective base values will be printed. Okay, so we can use this function as and when required, but I don't have any use case for this function as of now. The next functions are parseInt and parseFloat. ParseInt is a more flexible way of converting string values to number. For example, if we run this statement where I'm trying to use parseInt function, and I'm passing this in string value 1000 pixel, so it will convert this string to 1000, and this will be returned as a number. And in the next example, I have taken this string AB1000, and when I'm trying to use this parseInt function, it will return NaN. So what is happening here is that in this first example, it will start reading the value from left, and it will keep reading the value until until it can't. So as soon as it starts reading this value P, it cannot read it. So it will stop, and whatever the value was already read will be returned as a result. So 1000 will be returned here. But in the second example here, the first character itself is an alphabet, so it cannot read any further, and NaN will be returned as a result. And parseFloat works on the similar lines, and so it can also convert the string to its to decimal if the string contains the decimal part. I have added a note here that parseInt and parseFloat read a number from a string until they can't. If no digits are read, then NaN is returned. Digits are read from left to right. So we start reading digits from left, and continue reading towards right. The last function that I have mentioned here is the toFixed. toFixed is used to return the fixed digits after the decimal point, and we pass this number as a parameter of this function. If no parameter is passed, then no digits will be present after the decimal point in the result. So in this first code snippet, I have used number 12.34363464. So, and I use this number toFixed and pass value 3. So it will print a number 12.344. So uh, it is only going to contain 3 digits after the decimal as the value in the function I passed, and the resultant value will also be rounded off to its nearest value. So in the next code snippet, I have tried to show you that the result that we get from toFixed function is of a string type. So if you run this statement, it will print a string. All right, so let's move to next slide. In this slide, we will talk about the Bigint data type. So what is Bigint? Bigint is a recent entry in JavaScript data types. Bigint was introduced in JavaScript as a new data type in, I think, 2019. So it's totally different from number data type, and it was introduced to overcome the problems that we face while using the number data type. So in our previous slides, we talked about there are some restrictions in using the number data type, that the maximum precision value can be 17, and if we try to use bigger integer values, then they are not correctly represented, and there are chances that they will induce the errors in our calculations. So to remove those kind of barriers and restrictions, and Bigint was introduced in JavaScript. So how can we create a Bigint number? So we can create Bigint by appending n at the end of an integer. So we have, let's say we have an integer, a very large integer, and we want to store it as a Bigint. Then we just append n at the end of the integer value, and it will be converted to Bigint. And if you run the command of if you try to find the type of this number function, then you can use type of function, and it will return Bigint rather than number. And Bigint function can also be used to create Bigint values out of a string or number. So if we have a large string value, then and we want to convert it to Bigint, because very large string values cannot be converted to integer, and even if they are converted, they will not be correctly represented. So we can use this Bigint function to convert the exact same value to Bigint from the string. And we can also use this function to convert number type to Bigint type. So that's it for today's session. And in the next video, we will go through the coding session where we'll discuss and see all these points in action. If you have any questions for the points that we discussed today, please let me know. I'll be happy to reply. And thank you for watching, and see you in the next session.